Okay, hello everybody. Hello. How's everybody doing here this fine afternoon slash evening? Hopefully everybody is doing absolutely fantastic. All right, welcome back to some Math 126, some business calculus. Good to see everybody here once again today on this fine Wednesday. Hopefully everybody's doing very well here today. Yeah, we got a lot to do here on the docket. We got some very important concepts here. Actually, I should say probably the most important concepts here we got to get going here today. So definitely have some important examples and whatnot here to go over for today. So I want to welcome everybody here who decided to pop on into the stream. So hopefully again we're having a very relatively easy, relaxing afternoon. So just we're just having a good old time. That's all what it's all about. So, well, we got some important stuff. Regardless. All right. Drink some. Drink some of this kombucha. Oh, this. Actually, there's a thing on here. Okay. Kind of surprising. All right. There we go. There we go. Hey, Lee Wen. Hey. How you doing? I'm doing absolutely fantastic. How are you? How was your day so far? Your day going pretty good? I hope your day is going pretty good. So hopefully you've had a chance to relax a little bit. Is this your only class of the day, Lee Wen? Or is this or do you have more than one class? I'm glad to see you're doing great. It's very good. Yes, your only class of the day. Very nice. Oh, that's super convenient. Get a chance to sit back and relax a little bit. Feel like here in the evening. Oh, still feeling the effects of I took a little nap in the afternoon. Like, oh, I'm tired. Uh, got one more day. Sleepy, I know. I was like super. I like had this energy, and it was just like doing a lot of different things, and it just kind of sapped my energy. I'm like, I need to rest for a little bit. I need to relax for a little bit. Get the batteries recharged. Like I can do this class here at 6 o'clock. I shouldn't have too much of a problem if I just get a small little tiny cat nap of an hour and a half in. So which yeah, honestly, this today shouldn't be like overtly too bad to do. So just gonna concentrate a little bit on the first part there, but once we got that down, it shouldn't be terrible. So should not be terrible. Just waiting for a few more people to come on in, and we're gonna go get started here. I end up starting just a little bit later, so we can allow people to come on in. So, but yeah. I don't know. You got plans for this weekend, Lee Wen? I don't know if you have plans this weekend, if you have plans to go out somewhere. It's nice weather out. It's summertime. I have plans to go out places this weekend myself, so I gotta meet a friend in town. So it'll be like one of the rarest times I'll have a social life. Do homework? Oh my goodness, no. Oh no, do homework. Oh. I'm not even sure that's the right answer. Oh my goodness. That's not living. Living is not just doing homework all the time. Oh my gosh. Oh my goodness. Hey, Elizabeth. Yeah, it's time for homework. That's true. You're working 42 hours. Yo, rip. Rip. We've been there before. Working a bunch of hours. I've been there before. I've had many jobs in the past. Done my 40 hours a week many, many times over. I were used to work retail or work at Six Flags or work at Jewel. Yeah, I've done a bunch of jobs. I ain't gonna lie. I got paid like my first job was Mickey D's, so that was my very first job was at McDonald's. So back in 1995, yes, at Mickey D's, getting paid $4.35 an hour for being a cashier and doing fries stuff. Yep. You refuse to work at fast food restaurant? Well, I'm going to tell you one thing. Albeit this my first job, in all honesty, Elizabeth, it was my first job, and I learned a lot off of that first job. Probably I learned a lot of valuable lessons working at McDonald's. You're probably saying, you're like, well, that job's kind of beneath me because, it's like fast food and it sucks. I said, yeah, technically that's true. Okay, it's not the greatest job in the whole wide world, but one thing it did teach me is that you can't actually put a job beneath you. A job is a privilege to have. You're getting money, even though it's not the greatest amount of money. You're still working hard for it, and you still have to understand. Even if you're at the bottom of the barrel, you're still earning money. And sometimes, I always go back and say, you know what, I can't look a gift horse in the mouth when it comes to like earning money if I don't have any. So, uh, I don't put anybody's job beneath me because of that fact. So, having that experience was really super valuable for me to get to know that how hard I had to work to get the money that I wanted. Because at that time, at least I was a teenager at the time, I was 15 years old, right? And so I wanted something really bad, and I had to work really hard to go get that certain something I wanted. I just don't like fast food or how it smells, but always blessed to eat. Yeah. So yeah, I always had to recognize that. I don't need to be fast food, but everyone should work one food job, knows dealing with those customers. Yeah. You know what? Working with customers and customer service, I've done customer service before as a separate job. Um, but technically, fast food is like a customer service job anyway. Yeah, it's just like understanding that perspective is also very important as well. There are going to be days where people are going to treat you like absolutely terrible, and just like that's just how it is. But you keep on going, you keep on pushing. That's just that's just part of life. So, but people work very hard for doing what they do. So it's like whenever it's not you, Elizabeth. It's like saying, no job, regardless. And you know that, Elizabeth, based on what you just said. It's like, hey, no job is ever going to be like, below you or anything like that. So first job, I had to call the police 3 times because to come in because of customers. Oh man, that's rough. That's a rough go. Yeah, customers being unruly or not being very nice. We had a few issues when I was customer service over at the very old and now definitely long gone company of Circuit City. So basically I had that going on there. Some lady came in drunk, offered him payment. What? Oof. Oof. That's a rough go. You're just lucky you could refuse the service. If it was like an emergency room, you can't refuse those people. You can be like, you gotta try and get them detoxed off of the pills and stuff. Well, one of my cousins said he works in the ER. I was like, oh my gosh, so much work. All right, we gotta get going here, ladies and gentlemen. Let's go ahead and get going here. We got some important work to do here. So today, gonna be lots of examples here today. But if we go by this rather slow, we're gonna be in pretty good shape. All right, so let's do some intros. Let's get going here. Okay, let's get started today. Welcome back to Wednesday. All right, so for today, we're going to pick up where we left off last time. Last time we did section 3.2. We talked about the product and the quotient rule here. All right, so we did examples in regards to product and the quotient rule. We looked at how to basically find out derivatives using those two particular rules. Now today, we're going to be talking about one more very important rule here when it comes to derivatives, and this next rule here is going to be the big one, okay? This is the rule that is going to be used throughout the rest of this course, okay? And especially in calculus. You will use this rule again and again and again and again and again. If you don't know this rule and you don't get comfortable with this rule, the rest of this class, regardless, is going to be really, really hard if you don't. So I'm just going to make it as cut and dry as that. It is that. It's just going to be like that. And so what am I referring to here? Well, let's go to the big board here. Switch cameras for a second. Go. All right. All right. So the rule that we're trying to cover here for today, ladies and gentlemen, is going to be referencing the chain rule. All right. So the chain rule here in section 3.3 is going to be our friend. So what is the chain rule here? Well, the chain rule is what you see here as the actual notation and whatnot. So it says derivative with respect to x of g of f of x is equal to g prime of f of x equals g prime of f of x times f prime of x. Now, admittingly, in its notational form, it looks like a collective nightmare. And I don't really like the notational form. It's not really that easy to remember. So instead, I paraphrased it to make it a whole lot easier to understand. So a better way to remember here, as you can see, is that we take the derivative of the outside being the outside function, we keep the inside the same, and then we take the derivative of the inside, okay? Now you're probably saying, how exactly does that work with actual practical things? You're like, this is just a bunch of words, or that's just a generic sort of thing with a bunch of letters. I said, fine, that's fair. All right. So we're going to look at several examples here for sure to kind of get comfortable with the idea of using the chain rule and finding out just that derivative. All right. So what I'll need for you guys from you guys here today is I'm going to need your participation here today because I want to see where everybody's level of understanding is regarding this particular topic since it's very heavily used pretty much throughout the rest of the course from here on out. Okay, so we're going to go with an example here of a particular function and we'll take a look at what that derivative is going to be. Okay, let's start off with something nice, okay? So here we have 2x squared minus 3x plus 7 to the 5th power. Okay, so all that stuff there to the 5th power. Now, we do have one big issue with this particular problem. So here's where the chain rule is very helpful. If you try and expand out something to the 5th power, this is going to be a super duper long expression. So if you're trying to rewrite it, actually foiling everything out to the 5th power, it's going to take you a long time just to get there. Obviously, you don't want to do that. So it's going to be very, very messy very, very quickly. Now, what we're going to do here specifically, though, is we're going to apply the chain rule here. We're going to take the derivative of the outside, we keep the inside the same, and then we'll multiply that by the derivative of the inside. So the question is, what is the outside function? Okay. So the outside function, okay, actually, why don't you guys take a guess here? That's fine. A guess is fine for this one. What do you guys think is the outside function here according to this particular problem? X to the 5th. All right. That's correct, Nick. All right. So the 5th power here is going to be our outside function. Very good. And what's the derivative of, say, x to the 5th? What's that derivative? Well, I agree with what you're saying here. That's a good guess there, Nick. I like that. The derivative of that. Okay, that's right. The derivative is 5x to the 4th. All right, so both Nick and Ackle are correct. Now, so here's how we're going to approach it. Okay, I want you to think in terms of that 5x to the 4th. So basically, the derivative to the outside here, we're going to bring that 5 over to the outside. We're going to keep the inside the same. I'm not going to touch the inside. I'm just focusing on the outside here. So the inside here is still of 2x squared minus 3x plus 7. And we'll take that to the 4th power now because, of course, that's 5x to the 4th that both of you have correctly stated is the derivative of that outside portion. So that's half the problem done already. So we have the outside part there done. Okay, now we want to multiply that by the derivative of the inside. All right, so now we want to multiply by the derivative of the inside. All right, and what is the inside function here then? What's the inside function here then? Remember, I'm just thinking in terms of simple terms, outside, inside. All right, what's that inside function here? Okay, very good, Elizabeth. That's correct. So if that's the inside function there, the 2x squared minus 3x plus 7, what's the derivative of that particular function? It's the derivative of 2x squared minus 3x plus 7. 4x minus 3. That is correct. Very good. So this is going to be our derivative of this particular function. We took the derivative to the outside, kept the inside the same, then multiplied that by the derivative of the inside, and we got ourselves a winner chicken dinner. So this is what we got here for the derivative of that function using the chain rule appropriately. Okay. Are there any questions about that? We're going to do a whole lot more examples here, but I want to be sure that at least it's understood. This is the basics that we're going to be doing here for a lot of these different problems. Any questions so far? Again, if you have a question there, just please let me know. Otherwise, type no in the chat if you do not have any questions. Okay. All right, let's do another example. Still not sure how we got the second part here of 4x minus 3. What we did was we took the derivative here. This is the derivative of the inside function here. That's the 2x squared minus 3x plus 7. So again, just say to yourself here, Ashley, like, okay, you took the derivative of the outside. All right, you took the derivative of the outside, kept the inside the same. That's why we have the 2x squared minus 3x plus 7. Then we took the derivative of the inside here, which was 4x minus 3. So that's that direct derivative that we have there in that case. Okay, so it's always going to go outside, inside. So I just want you to kind of think of in those simple terms there, Ashley. I'll say outside, inside. So again, we just used the power rule on 2x squared minus 3x plus 7, and we got 4x minus 3 as a result. Okay. Okay. Let's try another though. Ashley, we're going to do a lot of different examples here, so I want to give you as many different looks as possible here. So we're going to look at this here carefully. All right, so here we have the square root of 5x squared minus 3x plus 2. Okay, now we want to find the derivative of this function here. Okay, so how can I rewrite this problem here? What could I do? What could I do to rewrite this problem in this case? How could I make this a little bit easier to see about how to use the chain rule here? Like here we have a square root, right? What's another way to write a square root? Does anybody remember? Another way to write a square root here. All right, to the 1/2 power. That's right. Okay, very good. So we're going to just rewrite this, right? We can rewrite this as 5x, oops, helpful here. 5x squared minus 3x plus 2. I can rewrite the square root as the same thing as saying to the 1/2 power here. One of the properties here of being square roots. All right, x to the 1/2, that's correct, Emma. Very good. Okay. Now, we want to take the derivative of this. Again, it's pretty much the same thing as the last example. All right. So again, we're going to do outside, inside. All right, so outside, inside. All right, so let's do outside first. What do we get for the outside? We get for the outside, what's the derivative of x to the 1/2 there? Uh, 2.5 2.5x minus 3. Okay, you're trying. Okay, I see what you're trying to do there, Emma. Not quite. You're trying to mix two things together. So I want you to take a look at it as two separate pieces here. Okay. I want you to take a look. You just have that. Let's say you have all that stuff there. That 5x squared minus 3x plus 2. You have that to the 1/2 power. The outside function here is just that to the 1/2 power. So I just want you to concentrate on that part there. Just concentrate of some gobbledygook to the 1/2 power. Doesn't matter what that gobbledygook is. Okay, that's correctly went. So again here, Emma, we're going to take this 1/2 here. We're just going to bring it here on the outside. All right. We're going to keep that inside part the same here. Okay. So we want to keep this 5x squared minus 3x plus 2. We're not going to switch that around. Not touching that here. We're going to keep it exactly as it says. Okay. So that inside there stays the same according to the rule here for the chain rule. And then of course we take 1/2 minus 1, so we get to the negative 1/2 power. Okay, so I want to be sure. Does that make sense about why it turned out to be that way? Now I want to be sure that you understand that that's the outside being done here, and then we're going to multiply that by taking the derivative of the inside. Okay, good. So I'm just going over carefully over each part here. What's the derivative of the inside? Okay, so we're going to multiply that by the derivative of the inside here. What's the derivative of the inside? The inside being 5x squared minus 3x plus 2. What's the derivative of that inside here? What's that going to be here in this case? 5x squared minus 3x plus 2. What's that derivative there? All right, 10x minus 3, good. All right, good. No problemo. Okay. All right, any questions about that? Any questions so far? Okay. Again, there's going to be a lot of different types of problems we're going to be looking at here. So again, buckle in. We're gonna look at a lot of different types of looks. So let's try the next one. All right, cool. All right, next one on the docket here. Yeah. All right. Sure. All right. I'm going to inch our way up here just a little bit. Okay. So here we have 3 over the cube root of 6x squared minus 5x plus 3. All right, that's what we have here. Okay, now, what we need to do here first is we need to rewrite this problem. As it stands right now, this problem is really, really ugly. Okay, so again, you have something divided by something else. It looks pretty rough to do, right? It's not the nicest thing to look at in all honesty. Okay, now all those claims there are definitely valid. Okay, 100%, very, very valid. So let's go ahead and rewrite this problem here first before we apply the chain rule, and then we can go ahead and apply the chain rule once we have it in a much more simpler form. So sometimes, like I said, some questions here are going to just require us to just move the deck chairs a little bit to something a little bit more manageable. So in this case here, let's look at the denominator here. We have the cube root, okay, of this. What's another way to write the cube root here again? You kind of did this with the square root one, but what's another way to write the cube root here? That's the question we have here. So, all right, to the 1/3. Completely agree, Emma. All right. So I agree with that. Now, we can be kind of satisfied with this. We got something something to the 1/3 power. Seems fair. All right, but we can take it one step further. What if I move this to the numerator here? What would happen if I move this whole expression to the numerator? If I move this to the numerator here, what happens to the exponent? What happens to that exponent there if I move this to this whole expression here to the numerator? So I have it to the 1/3 now, but now that becomes what? All right, that becomes to the negative 1/3. Okay, good. All right, so that's correct. We're going to move that to the numerator. We take to the negative 1/3. So now we have it in a much more manageable position, all right, where we can start taking the derivative of this particular function. So let's do it. All right, so if we're going to do this particular problem here, again, we're going to approach it the same way. Do you understand that this 3 here on the outside doesn't do a whole lot outside of just multiplication? Negative. Yes, negative 1/3 is what I have here. Right, to the negative 1/3 power. So all I'm going to do here is I'm going to bring this 1/3 out. So I'm going to have 3 times negative 1/3. Keep that inside the same. Yet I'm doing the outside portion here first. Okay, don't forget I am subtracting this negative 1/3 by 1. If I subtract this by 1, right, because that's what I'm doing, then that's going to be negative 4/3 here as my result. Okay. Then I take the derivative of the inside, which is pretty easy. That's going to be 12x minus 5. So I can multiply this part on the outside. That's really not hard. We just just have a negative there. So slightly a bit of cleanup here. Nothing too major. And so this is our final answer for this problem here. There we go. All right, any questions about that so far? So that's the derivative of that particular function. Again, once we rewrite it into something, again, we can just, it's much more manageable, and then we can go ahead and apply the rules that we just had from before. Okay, so we've taken a look at a few examples here, but we're not quite there just yet. Now we need to turn it up just a bit. Okay, so now we looked at, they're probably saying, you're like saying, we'll say, what? I'm like, yes. There's slight. Oh, my stream dropping frames. Particularly odd. Just a second, folks. All right, can you guys see me a bit better now? As it is it stable now? Sorry about that. This doesn't happen as often as it used to. So if there's sometimes there's hiccups. So streams not is it choppy on your end, Leewin? Like is it choppy or is it a bit smoother? That's weird. Check that again. I don't have drop frames, do I? I had some. It looks like I did. Now it went away. So weird. Like nothing happened, and then it's like, okay, that's so random, man. Check that here. All right, so looks like there was a slight hiccup, and then it kind of went away. All right, it's better. Okay, all right, fine. That's kind of weird. So, oh well, I'll just have to live with it. But as long as if it's smoother on your end, that's fine. Leewen, Ashley, you guys okay? You guys can hear me pretty easily now. Hopefully the not choppy on your end or anything like that. Yeah. Okay. All right. Good. 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 Sorry for that slight delay. Apologies about that. That hasn't happened in a while, so um, like I got the settings just right, and sometimes my interwebs they're like, nope, we're gonna poop out on you. Like, okay, thanks, man. Thanks for pooping on me. It feels so great. Exactly what I've always wanted my whole life. Okay, there. I just did one more reset there. That should be probably good. All right. Okay, so let's go ahead and do the next problem here. We're gonna crank it up here a notch, and we're gonna see exactly how things work out. So next one here, I'm gonna make up on my own, but it is a relevant problem nonetheless. And yeah, that one's pretty okay. Let's go with I want to, yeah, you know what? You know what? That's pretty relevant. Let's do that. Okay, so I'm just going to make this up as I kind of go along here, but its relevance here is very, very important. Okay, so here we have 2x to the 2x plus 5 squared times 7x squared minus 22x plus 3 to the fourth power. And we want to go ahead and find the derivative of this particular function. Now, once again here, you could go ahead and FOIL it out and combine it together, and that's going to take you a heck of a long time, and it will make you incredibly sad on many levels. So obviously you don't want to do that, right? Um, let's avoid that altogether. Okay, now if we want to take the derivative of this particular function here, all right, we're definitely using the chain rule here. That goes without saying. But what else are we going to be using here as well? Are there any other rules that we can use here in order to find the derivative? What do you think? Are there any other rules that we can use here to find the derivative? Besides the power rule, of course. So let's put that question down there. Any other rules we will use besides the chain and power rule to find the derivative? What do you guys think? I will tell you this, there is one more rule that we're going to be using here in this problem. Now it's going to be on you to recognize that this is what you're going to have to use here in a problem like this. Okay, that's correct, Lee Wen. The answer is the product rule. Okay, so really quick here, let's talk about the product rule here really quick. Talked about it yesterday. So that rule that we talked about here yesterday, what was the product rule, by the way? Anybody tell me, give me a reminder here. What's the product rule? What was that product rule here? Anybody give me the product rule? What was the product rule we talked about here yesterday? Again, I know I'm going to be really big. I'm going to ask a lot of questions here today, guys. So, again, this is kind of like gauging your level of understanding here. Because, like I said, f prime g plus g prime f. That's correct. I'm going to gauge your understanding here because this is, like I said, this particular section here is the make or break it. Okay, so there's no two ways around it. So knowing your rules from before and then combining it with this rule, the chain rule here, very important. Okay, very good, Lee Wen. That's correct. So Emma, Lee Wen, that's correct. So f prime g plus g prime f. Okay, that's our product rule there. All right, so what we're going to do here is we're going to have f here to be this first guy. We'll have g here be this second guy. All right. Okay, so let's put this together here, and let's find out what f prime is. Again, we're going to just take the derivative of that first function there. And again, in order to find the derivative of that first function of 2x plus 5 squared, all we need to do is do the chain rule there, and we're going to be able to find that no problem. So again, the chain rule here, going to be applicable here in this case. So this one here, again, bring out the 2, keep the inside the same, 2x plus 5. That'll be to the first power here since we have 2 minus 1. And then we multiply that by yet another 2, which is the derivative of the inside. So that is the derivative of the first function there, using the chain rule there appropriately. All right. All right, now it's your turn here, everyone. What is the derivative of this second function here? What's the derivative of this g function, the thing I found is g? What is the derivative of g in this case? What is the derivative of g here? What's that going to be here? And this will take a little time to type out. I totally understand that. Three. Okay, so that's the first half there. All right, Lee Wen, that's the first half. 37x squared minus 22x plus 3 squared, plus 3. Oh, oops, not 3 here, sorry. Kind of messed that up. We have a 4 out here. We have a 4 out here, Lee Wen. But you have the right idea. Or 14x minus 22. Okay, Ackle, you're trying to do 2 things at once, okay? So what you're trying to do there, Ackle, is you're trying to do 2 things at once. All right? So what I want you to do is do it as 2 separate parts, okay? So listen carefully, okay, Ackle? We got the derivative of the outside is first, and you keep the inside the same. So again, probably in your notes here, very important. Let's go back to the notes here for just a moment. You keep the inside the same. So I put that in parentheses on purpose here. Okay. So Lee Wen, change the first number from 3 to 4. Change the first 3 to a 4, and then you got it. So again, going back to our notes here, it says we want to keep the inside the same when we take the derivative of the outside. Okay, so what you're trying to do there, Ackle, is trying to do 3 things at once. But what I'm trying to tell you is that you have to do it in separate steps if you're going to do the chain rule there correctly. So it has to be done in separate steps. All right, so like I said, don't try and go from point A to point B here, at 100 miles an hour. We want to go at it slow here so we can get each piece down as we appropriately use the chain rule here in this case. Right. This is definitely one of those things that's why I'm going super slow, because I'm like, you know what? It's not going to make sense if I do 3 things at once. So you see I'm doing 4, bring the 4 out here, keeping the inside the same. I take that to the third power there. Okay. And then after I've taken the derivative of the outside and kept the inside the same. So I'm done with that part there. Now I go ahead and take the derivative of the inside, which is correct to say that is 14x minus 22. So that's where that goes specifically, is once you've done the outside portion, multiply that by the derivative of the inside portion here of 14x minus 22. So now with that, specifically, by the way, now with that, we're going to go ahead and use that now with the product rule, because now we have f prime and we have g prime here based on these two functions. We're now going to use the product rule, and we're going to put it all together in a grand final answer. So we have f prime g, so let's at least put that down. We have 2 times 2 here, by the way, that's going to be 4. I'll put 4 there for that. So 4 times 2x plus 5. I just cleaned this up a little bit, by the way. Just a smidge. So we have f prime g. So we have g here. That's going to be the 7x squared minus 22x plus 3 to the 4th power. That's f prime g plus g prime. That's this whole rigmarole right here. I'm going to put that right down here. So g prime. So this is just g prime that I'm writing down. And then we write an f, which is 2x plus 5 squared. And so this is our derivative of our function. This will be our final answer for this problem. All right. So far, so good. Okay, that worked. I can do that. Questions about that? Hopefully that makes it a little bit more clear. We're going to do another question though, but hopefully that makes it a little bit more clear there. Again, if you have questions, please let me know. Otherwise, type no in the chat and I'll move forward with the next example. Okay? All right. Let's look at the next one here. All right. I'm going to crank this up even further, just a bit. So, yeah, we're not really, this is like the no screw around territory, I suppose is the best way to put it. All right, let's do it that way. Oh my goodness. Okay, sure, why not? I can do, which, yeah, I do it that way. Sure, I'll do it. What? Okay, let's take a good look here at this particular problem. All right, so now we're just, again, we're ramping it up just here, just a little bit. All right, using the chain rule here once again. All right, so we have 3x squared plus 1 to the third power over the square root of 5x to the third minus 2x plus 7. Alrighty, seems fair. Now, one thing that you can do right here right away is, of course, change that square root. You can certainly do that. So that'll be the first thing that you should probably do here. Just change that square root into its appropriate power that we talked about before. So you can write it as 5x to the third minus 2x plus 7. We'll take that to the 1/2 power. Okay? Now, let's take a look at this carefully. We are going to definitely use the chain rule here. You know, no doubt. Power rule, sure. What other rule are we going to use here? What other rule is going to be our winner here? I'm going to use another rule. What other rule are we going to use here in this particular problem? Yeah. Okay, the quotient rule. That's correct, Emma. All right, so we have the quotient rule here. All right, seems fair. Anybody tell me what is the quotient rule? What is the quotient rule? I agree. The quotient rule is definitely the way to be. What's the quotient rule here? F prime g minus g prime f all over g squared. Very good. That is correct. So one of the easiest ways to remember, f prime g minus g prime f over g squared. All right, so there we go. Got it. All right, so we're just going to define our f and g here, and we're just going to go ahead and apply our chain rule to both. So again, we have f here. Let's put this in black here. We have f here. We have g here. All right, fine. All right, let's go ahead and find each of our derivatives here. Now this time, though, I'm not going to say anything. You guys are going to fill in the blanks for me. Okay? Let's take a minute. Let's take a minute or so here. If you guys can tell me what is the derivative of f, that function for f, and what is the derivative of that function for g? Okay? Well, the derivative of function for f and the derivative of the function for g. Take a minute here. You guys work on that. And type it in chat once you guys have that. And again, I don't need it simplified or anything like that. So okay, so Nick says f prime is 3 times 3x squared plus 1, 3x squared plus 1 quantity squared. Okay, so Nick, you have half of it correct. Elizabeth, you also have half of it correct. In fact, both of you have 1/2 of. You guys have 2 different halves that are correct. You just guys have put those together. Like Nick brought 1/2 and then Elizabeth brought 1/2 and then you just had to kind of take away. So Nick actually didn't have anything to take away, but all right. So smushing them together, yes. Okay, good. All right, so that's correct here. Both. Okay, good. Lewen and K, that's correct. So we have 3. Well, at least let's write that down. 3x squared minus 1. Right. Quantity squared and times 6x. Agreed with that. All right, so behind you both here on that one. As the chain rule there for that one. Okay? Seems fair. How about G? G prime. 6x comes from the derivative of the inside, Nick. What's the derivative of 3x squared plus 1? That's where it comes from. Remember, derivative of the outside, keep the inside the same, and then the derivative of the inside. Yeah, don't forget about that. Two halves to this particular chain. There's two halves of the chain rule there. It's always going to be that way. Okay. Cade says 1/2 5x to the third minus 2x plus 7 to the negative 1/2. Okay. And 15x squared minus 2. Okay. All right. That is correct. All right. Very nice. That is absolutely spot on correct. So here we get that to the negative 1/2. All right. And then we take, that's the derivative of the outside, and we get the inside there. All right, Lee Wen, that's correct. What am I doing? That was a my bad there. So 15x squared minus 2. Okay, that's correct. So we have the derivative of f, all right? We got 3 times 3x squared minus 1 and squared times 6x. And then g prime there, that whole mess there, 1/2 times 5x cubed minus 2x plus 7 to the negative 1/2 times that's respective derivative on the inside, which is 15x squared minus 2. All right. Very good. Very good. That's correct. Okay, now we just apply our quotient rule that we have here, and then we're done. Okay, so just follow the quotient rule here. We have f prime g minus g prime f, and we'll put that over g squared. So f prime g, so here we have f prime. So we'll just go ahead and put it as a raw f prime. Exactly what we have written there up above. So f prime g, so we have g here again as 5x cubed minus 2x plus 7 to the 1/2. Minus g prime. That's going to be this whole big old ugly looking thing, but you know what? That's g prime, so got to do it. Let's plug it in. Actually, I'll put that in purple. Highlight that. We get 15x squared minus 2. Okay, and then that's g prime f, and f is that. Okay, so 3x squared plus 1 to the third power. All right, and this is all over g squared, and in this case here, g squared, actually, if you square g, it's like squaring a square root. So squaring a square root just cancels out the square root. So in fact, all we actually end up with is 5x to the third minus 2x plus 7. That's what you essentially end up with. But if you wanted to just kind of write it raw, you could technically write it as the square root of this, quantity squared. But you know for a fact that this quantity squared would cancel out with this guy. So again, whichever way you would want to write that, that's fine. There you go. Okay. So you can see that, yes, the answer is, without a doubt, the answer is incredibly long. Okay, there's no question about that, right? But I wanted to showcase here at least a lot of different problems with a lot of different looks here about how we're going to be approaching some functions that we're going to be looking at here that definitely are going to be using these rules here over and over and over again. So, like I said, this is not the last time you're going to be seeing this, not by a long shot. pretty much every section after from here on out has functions that use the chain rule. Okay, so yes, this is something that you absolutely need to know, and like I said, is probably the linchpin of the class right after this section. So basically, I kind of liken this question as like the gloves are off when it comes to like doing derivatives. So is once you start introducing the chain rule, things start to get a little bit more complex. So okay, questions about that before we do the next example here? Nope. Okay. All right. Slightly off topic, but can we use notes on the exam? I mean, I guess. Sure, why not? I guess. I don't know. I don't know how. It just depends. I give you a practice exam and whatnot, so I mean, you have a chance to go ahead and do it, I suppose. The only thing that you won't have is you won't have resources available to you. So, um, you won't have like online resources available to you, I guess is the best way I want to put it. If you do the practice test, you'll have the online resources available on the practice test. But if you try the actual test, you won't have the online resources available to you. So, but again, I highly suggest to do the practice test here first because that pretty much is exactly like the real test. So, honestly, if you use your notes, it takes longer to do. So, just going to say that outright. So, it's just traditional. If you ever rely on one crutch, it usually takes you much longer to do than actually just practicing it out. So you have this false sense of security. That's one thing I can just say right now. I know that for a fact because I once took an open book final, open book, open note final. And let me tell you about that. That was a disaster. And again, I didn't like that class anyway. Anyway, all right. Okay, let's go ahead and do let's go ahead and do this out here. So they give you a little bit of a function here. So I'm just gonna just kind of copying this here. Okay. So let me go ahead and read this out here. This is a application problem here. So it says the amount of digital information created each month globally is represented T months after the beginning of year 2008 is approximately, and they give you this function here. So T equals 0 is 2008. So, all right. How many billion and billions of gigabytes, by the way, this is billions of gigabytes. All right. How many billion gigabytes of information were created at the beginning of 2008? So that's letter A here. How many billions of gigabytes were created here at the end of 2008? So they just want to figure out, okay, what happens if t is equal to 0 here? All right, so you plug in 0 in for this first part. The first part here is like super straightforward. So here we have 400 times 0 over 12 plus 1 to the 1.09 power. So here we have 400 times 1 to the 1.09 power. All right, now 1 to any power here, by the way, is just going to be 1. Even if it's a decimal, by the way, it's still 1. So that's going to be 400 here, straight up. All right, so nothing too fancy. There you go. Yeah. Now, let's look at letter B. Letter B says, how fast was digital information being created at the beginning of 2010? So T equals 24, so 24 months here. All right, so this is T equals 24, but it says how fast. Okay, now, in this particular case, we want to go ahead and use the derivative here of this function. So we have to use the derivative of this function here. So can anybody tell me here? Let's take a look at this. We need to find what is the derivative of this function. What's that going to be here in this case? What is the derivative of this function here? We have 400 times t over 12 plus 1 to the 1.09 power. And here's a hint, we got to use the chain rule on this. So again, the 400 doesn't do anything, by the way. It's just going to be multiplied by whatever. So we'll clean that up afterwards. But anybody tell me here what's the derivative of, let's take a look at the derivative of, again, t over 12 plus 1 to the 1.09 power. What's that derivative? You guys have gotten good practice now. Now it's time to put it to the test in an application problem. Really, you're not doing anything different. What do you guys think? I'll wait. It's fine. Okay, 1.09 t over 12 plus 1 to the point and for half of it. Okay, that's right. I agree with that half of it. So I'm gonna include the 400 in here because we haven't done anything with that. So I agree with that half of it. That's right, Nick. What's the other half of that, Nick? Okay, so that's 1/2, right? The 400 here doesn't do anything. It's just going to be multiplied by the 1.09. Now you take the derivative inside here, which is t over 12. Now another way to write t over 12 plus 1, by the way, you could rewrite it as 1/12 t plus 1. Okay, you could write that inside just like so if you wanted to. So the derivative of that is going to be 1/12. So on the outside here you have 1/12, just like so. Okay, does everybody see where I got that derivative from? Again, just a little bit slight of a rewrite if you want to, if it makes it a little bit more clear about what that derivative is going to be. If it's going to help you at the end of the day, then go ahead and do that. Are there any questions about that so far? Any questions so far? Make sense? Okay. All right. So now we're going to plug in 24 into this gobbledygook. So this ugly looking thing looks pretty awful, but well, in reality, we're just going to plug in 24 into for t. There's only one t here, by the way. So looks like there's a lot more going on. Looks like there's a lot of it, but it's really there's only one place to put 24, and that's in that spot there. So we're going to definitely use the calculator here to, of course, find out what this is equal to because, well, that's a lot of numbers kind of smushed into one place. So kind of figuring that out here, we're going to have 400 times 1.09. All right, times 2 plus 1. That's 24 divided by 2 is 2 plus 1 to the 0.09 power. And then we're going to multiply that by 1/12. So going out to a couple decimal places here, we're going to get 40.11. 11? Yeah, 11. So that's how fast it is at t is equal to 24 being created in 2010. Okay, so again, that last part there is strictly calculator stuff. Again, should have that entered in there appropriately, and you should get your final answer to work out just like so. All right, any questions about that? Any questions, anybody, about the chain rule here? I hope that doing these examples here will make it a whole lot more sense than I want to give you as many different looks as possible. So I wanted to spend a lot of extra time on this guy, and I wanted to be sure that everybody was on board with this particular concept. Surprisingly enough, this is question 1 is the only question from this section, by the way, from this section. So yeah, on the handout it's just one question, but it encompasses so much. It's like an easy answer to like put on a piece of paper on the handout. But because there's so many different types of problems that use the chain rule, that's why it's a much more deeper question as opposed to just being one question on a handout. So the rest of the questions on the handout deal with the section 3.4. So let me ask you guys, how are you guys feeling? Are you guys feeling okay? Was this a little heavy on you? Or would you guys like to keep going? So I'll leave you the option here today. This was a very heavy section. So, you guys want to do, you guys want to start here with another question here from the handout? Or do you guys wanna, like, we can keep going, or we can stop here for the day. It's up to you, because I know that's a tough section. So I'll leave it in your hands for this one. All right, that's fine. Makes sense, but a lot to remember. All right, well, let's take a poll here since we have people from both sides here. That's fair. Manage a poll. Put a new poll here. All right. All right, we'll put it for a couple minutes here. So just in case. Everybody has a right to say. I understand if we're impartial, but I always give it the choice. We're in a democratic system here, so I don't discriminate either way. I just listen to what the masses tell me. So the poll is at the top of the chat there. You click on that, you'll have the choices there. All right, so less than a minute left. Those of you who haven't answered the poll yet, go ahead and answer the poll there up top on chat. Click on the poll, and then you can click on a radio button for either stop or keep going, whichever one you want to do. All right. Like we're about less than 10 seconds left. I think looks like there's a clear winner here. But I always go to the end just in case. All right, so this is a stop here for today. Okay, so the stop's winning here, 6-0. All right, so what we're going to do here, we're going to stop here for today. We're going to pick up here for section 3.4 here for tomorrow. All right, so we're going to do, again, applications here, average cost, marginal cost, and whatnot. These are actually pretty straightforward. They don't take too much time to do, but I think based on how much we did today, sounds like some people's brains are shish kebab fried. So we're going to go ahead and stop there for today. But yeah, good job, everybody. Thank you so much again, everybody, for participating here today. I'm very happy again with the participation. I'm going to keep asking you questions here again. I just want to gauge your understanding here. Okay, it's just a matter of just getting things done. Making sure that you guys understand what we're trying to do. That's like you ask here, I'm going to use notes on the test. Well, notes aren't very useful if you don't understand even what you wrote down. So, kind of, it's going to be kind of an important thing to kind of get to know even the notes that you're writing down there. So it's like Nick and Elizabeth be like, "I'll use the notes." Be like, "Yeah, go for it," but you got to understand what they actually mean. You're like, you wrote words in the paper, but hey, applications very important. All right. All right. All right, ladies and gentlemen, thank you so very much here for coming on ahead here to the stream today. All right, love you all here very much. Thank you so very much. You guys make this enjoyable. You guys make this fun and exciting. And I will see you all tomorrow, same time, same place. Again, should you need my help here, again, feel free to email me or contact me here through Discord, and I'll be more than happy to talk with you guys and help guide you through here. Again, if you haven't done so already, again, that first test there has been posted, so please go ahead and give that a go. All right, so, all right. Thanks again, everybody. Take care of yourselves. Have a wonderful evening, and we will see you all tomorrow, okay, for the end of the week. All right. All right. Take care, everybody. Have a great one. We'll see ya. And as always, stay safe, stay healthy, but most importantly, stay sane. Have a great one. Take care, everybody. Bye.